Today in this video, we're going to cover emissivity, and we're going to explain the importance of it when performing a thermal imaging inspection or just a thermal imaging walkthrough of either your home or a building. All objects at temperatures above absolute zero emit thermal radiation. However, for any particular wavelength and temperature, the amount of thermal radiation emitted depends on the emissivity of the object's surface. Here you see I have three different types of materials: a plastic bottle filled with hot water, a tin can filled with hot water, and an aluminum can as well. And then you have your cold water on the left. Now, the three bottles that were filled with hot water are all filled with the same temperature. So let's just focus on the three hot bottles for now. You can see that the plastic is emitting the most temperature, the tin can is emitting the least, and the aluminum can is in that medium range. Remember, all three of these bottles or cans are filled with the same temperature water. So, to the untrained person, this might seem like the bottle of water is the hottest. However, it is not. And you can see if we switch over to a different color spectrum, you can see as well the hot spectrum is the most vivid on the plastic water bottle. So let's take a look at this example of what emissivity can do to your thermal imaging camera. You can see that the stovetop is on and the kettle is not emitting any heat to the thermal imaging camera. However, it's reflecting the heat. That's the reason why when you look through the thermal camera, you're not seeing any heat being emitted off the kettle. The liquid inside is not able to emit the heat because of the material that the kettle is made of is reflecting the heat. And that's because this kettle is made of a metal material. And that brings us to our next topic, which is going to be emissivity table. Emissivity is the measure of materials radiating efficiency, like we talked about earlier. Now, on the emissivity table, a 1 implies that the material is 100% efficient at radiating energy. If the emissivity is at 0.2, that implies that the material radiates only 20% of that which is capable of radiating. So you can see here on this chart that non-metal materials obviously emit way more than metal materials. So let's take a look at a few examples. Here you can see that the chimney has a square spot on an infrared thermal camera showing a hot area. Now, if someone is not trained, they could point that out and say that that might be water or a moisture issue. However, when investigated further, you can see that there's a beehive behind the chimney that's emitting the heat to the thermal camera. Here's another example. You can see here that you have a aluminum HVAC duct running through, and there's some white paint on it. Now, when you look through that on the thermal camera, that white paint actually has a higher emissivity level than the aluminum, and that's why when you look in the thermal camera, it's pointing out pretty obvious. Let's sum up what we learned today. Emissivity is the ratio of heat radiated from that type of object. You can have different types of materials from aluminum to brick, non-metal, metal, and the ratio of the amount of heat that it can emit to the thermal camera will vary.